Have you ever stared at one of those packing problems and just your brain freezes up? Well, today we're going to tackle one of those classic puzzles together. We're going to break down volume, figure out how to fit everything in just right, and even calculate all that pesky leftover space. I mean, we've all been there, right? You're reading the question, the words are just swimming around on the page, and you have no idea where to even start. Don't worry, today we're going to take one of those problems and pull it apart piece by piece. So, here's our situation. Let's meet Haley. She's got a whole bunch of these identical cubes. Each one is 4 inches, and she's got a big shipping box. Our job? Figure out exactly how many she can pack in there and what to do with any extra room. Okay, first things first. Before we even think about that big box, we've got to understand our basic building block. And that's one single cube. So the key idea for this whole thing is volume. All that really means is how much space something takes up in 3D. And the formula for it? It's beautiful, it's simple. You just multiply its length times its width times its height. Now, looking at Haley's cubes, we know 2 really important things. Number 1, it's a cube. That means its length, its width, and its height are all exactly the same. And number 2, we know that magic number is 4 inches. Every side is 4 inches long. With that info, the math becomes pretty simple, right? We just need to multiply 4 by 4. And then multiply that result by 4 again. Go ahead, take a second. What do you think you get? You got it, 64 cubic inches. So every single one of Haley's cubes takes up exactly 64 cubic inches of space. This number is going to be super important, so let's lock that in our minds. All right, part 1 is done. Now for the main event. We know how big 1 cube is. Let's see how many of them we can actually cram into Haley's shipping box. Okay, here are the stats for the box itself. We're working with a space that is 36 inches long, 24 inches wide, and 19 inches high. These are the boundaries of our puzzle. To figure this out, we just have to look at one dimension at a time. So for the length, we take the box's 36 inches and we divide it by the cube's 4-inch side. That gives us a perfect 9 cubes. Then we do the same for the width. 24 divided by 4, that's a nice clean 6 cubes. So far, so good. Ah, but here it is. Here's the little trick. Look at the height, 19 inches. That number isn't perfectly divisible by 4, is it? This is the little trap where people get stuck, because you gotta remember, Haley needs to be able to actually close the lid on this thing. And here's the absolute key. You can't chop the cubes in half. We can only fit whole, complete cubes in the box. So when we divide 19 by 4, we get 4, but we have a remainder. That means we can only stack the cubes 4 layers high. That leftover 3 inches at the top, that's just gonna be empty space. So now we have our 3 magic numbers. We know we can fit 9 cubes going along the length, 6 cubes going across the width, and only 4 cubes stacked high. To get the grand total, we just multiply them all together. And there we have it, 216. Haley can fit a grand total of 216 cubes into her box and still get that lid shut tight. The main puzzle is solved. But hang on, we're not quite finished. What about all that empty air at the top? You know, that space is going to need some packing peanuts or something. So how much empty space are we actually talking about? Now, what's really cool here is that there are actually 2 different ways to find the answer. You could go the long way, the subtraction method, where you find the total volume of the whole box and then subtract the volume of all 216 cubes. Or you can use a clever shortcut, the leftover slice method, and just calculate the volume of that empty gap at the top. Let's look at the numbers. Method 1, the total box volume is 16,416, and the volume of all our cubes is 13,824. Subtract those and you get 2,592. Now for the faster way. We just find the volume of that empty slice, which is 36 inches long by 24 inches wide by 3 inches high, which also gets us 2,592. See, it's awesome when 2 different paths lead to the exact same place. So there's our final answer to the second question. 2,592 cubic inches. That's exactly how much packing material Haley is going to need to fill up the box and keep everything safe. Okay, we have walked through every single step of Haley's problem. We broke it down, we found the twists, and we solved it. Now it's time to see if you can take what we've learned and apply it to a totally new challenge. So let's just quickly recap the 3 golden rules. First, always start with the volume of one single unit. That's your foundation. Second, play detective and check every dimension for those pesky remainders, because only full cubes fit. And third, remember you've got two tools to find leftover space, the big subtraction problem or the quick and easy slice method. All right, I think you're ready. Let's try this with a new set of numbers, but we're going to use the exact same logic we just practiced. Here it is, your mission, if you choose to accept it. This time, the cubes are 5-inch cubes, and the box has new dimensions, 40 by 32 by 20. Notice anything kind of convenient about those numbers? Okay, using the exact same steps we just went through, I want you to give this a shot. Can you figure out the volume of one of these new cubes? Can you find the total number that'll fit inside this new box? And can you tell me how much packing material is needed? Go ahead and pause here, work it out, and see if you've officially mastered the packing puzzle. Thanks for joining me.